This is our channel's latest in a series on doing things with geometric algebra, and in this video we will show how to find the radius of the circumcircle of a triangle, and later in this video I'll refer the viewer to a document that I wrote some time back on using geometric algebra, or more specifically rotations of vectors via geometric algebra, to solve a variety of different construction problems from classic geometry, including this one. So let's get started. Some of the ideas that we will use in this video are, first, that the area of a parallelogram is equal to the norm of the outer product of the vectors that form that parallelogram's sides. And as a corollary to that, of course, the area of a triangle is just 1/2 the norm of any two vectors that form sides of that triangle. Another idea that we will use is the relationship between the outer product of two vectors and the sine of the included angle. And you can work down through this a bit yourself. The norm of the outer product of these two vectors is twice the area of the triangle that's formed. So we come down to sine of theta is twice the area of the triangle divided by the product of the norms of these two vectors. We will also use an idea from a video that I will link in the upper right hand corner here that we did some time back. This is the relationship between the radius of a circle and the sine of an inscribed angle that subtends a given chord. So the radius of this circle here, which is going to be our circumcircle, is equal to the length of a chord divided by twice the sine of the angle that subtends it. So going on to our derivation for a radius formula, this is the diagram that we saw just a moment ago. We'll start from there. The radius, or in terms of our circumcircle and vectors here, the radius is the length of this side opposite the angle divided by twice the sine of that angle. So we'll bear this diagram in mind as we go to the next slide. Here the radius is the length of that side divided by twice the sine of the opposite angle. This expression, as we saw a moment ago, is the sine of that angle. So we've gotten this far up to this point, and we'll repeat this diagram in the next slide. Here it is. Now we use the fact that the norm of this vector is just what we call the length of the side, and similarly for b. So making that substitution, the radius is the length of the opposite side divided by twice 2 times the area over the lengths of these other two sides. We'll repeat this diagram in the next slide. There it is. Now we simplify, and we get that the radius is the product of the three sides divided by 4 times the area of the triangle. Now, what about the center of this circumcircle? Well, again, I'm going to refer the reader, or viewers rather, to a document that I wrote some time back, in which are solved several different classic geometry construction problems via rotations of vectors in geometric algebra. The document starts out with a presentation of different formulas from geometric algebra that are useful in plane or two-dimensional geometry, along with explanatory notes and just some hints. And also there is a chapter, before we get into solving anything, on important facts about tangents, chords, and angles. So with that preparation, we begin in the document to solve some of these problems. And again, for each problem, there's usually at least 2 solutions. So here's our circumcircle problem. And in each of these problems, we start off by identifying potentially useful elements of the problem. What does that mean? Well, we can see here different lengths, different angles, possibilities for rotations. So we identify all these possibly useful aspects of the problem, And then we go on, again for each problem. We formulate a strategy or perhaps multiple strategies for actually solving it. And of course there'll be side notes here with different observations that might be useful or to clarify questions that especially new or people who are new to geometric algebra might have. So I hope that you will consider looking up this document, which I will link in the video description. And I hope that you will also consider joining our associated LinkedIn group, Pre-University Geometric Algebra, and I will link that group in the video description also. Thank you for your time.